Today I want to look at the geometric series. I was asked by someone to see if I could find a good video for the geometric series, giving some actual substantial explanations. I looked around for about 20-30 minutes. I actually couldn't find any that I thought either weren't boring or were borderline completely useless. So why not make one, right? You can't find what you want, make what you have. So their specific question was in relationship to what is this expected value of x, or the mean of something happening is 1 over p. How can we put this into context? So I'm going to look at this example here and look at some of these examples below, and then I'm going to get to this letter D here and kind of put this into context. How can we use this expected value? And how does this relate to the geometric series at large, really? So let's see this first one. Okay, so the probability a basketball player made the foul shots during the season, so probability of a make is 0.75, and that means the probability of a miss. We oftentimes call this P. This is the probability of a success or something that we're looking for. I'm just going to leave it as a make, just so this can kind of hit home. That means the probability of missing is only 0.25, 25%. So the first question says, what's the probability that the player misses for the first time on the 5th attempt? So we have 5 attempts, and we want to know they want to miss on the 5th. So missing is actually our success in letter A. So in A, missing is a success. So we're not going to stop until we miss, and we want to know the probability of that. So that means the first shot is a make, 0.75. The second shot is a make. The third shot's a make. The fourth shot's a make. And then the 5th shot is a miss. Now, you might be looking at this and saying, hey, wait a second, this is repeated multiplication. And you're correct. Repeated multiplication is exponents. And so what happens here? Well, this individual, they missed 4 shots. And so the geometric series is the probability of failure to the power of the amount of failures times the probability of success. Well, our success in this problem specifically is the miss. And so typically, probability, our success is a miss. So in the geometric series, or not geometric series, the geometric distribution, we would call this P, and we would call this Q for letter A. And what the formula is P times Q, which is just 1 minus P, it's the complement, to the amount of trials minus 1. And how this is interpreted is that, well, we're doing something until we succeed. Well, that means that we're going to have that many failures minus 1. Our failures will be equal to the amount of attempts that we have minus 1. Because if we're shooting 5 shots and the last one's a make, well, that means that this would be 5 minus 1, which is 4. So sometimes people get a little bit too attached to this formula. I feel like these problems are very easy to do intuitively. And in fact, I teach these intuitively first and then introduce the notation second. Let's look at B here just because this switches around. It says, what's the probability that he makes his first basket on the 4th shot? Well, now we're going to flip-flop these. So now it's going to be a miss, and a miss, and a miss, and then a make. So, like I said, one of the reasons why I feel that people shouldn't get too caught up in the notation, because now our success has changed. Now our success, in contrast from letter A, our success is a make, which makes sense. So we have 3 of them. And that's the formula. I mean, really, I don't think this is a big deal. Again, you can really cling to this formula. I don't think you have to. I think these can be intuitively done. But, it does make sense. We have 4 trials, right? 3 of them are misses. 1 of them is a make. So this is going to be that number times 3. And then our last one's a make. All right, I'm going to jump down to letter D here. And it says, what is the expected value of the number of shots until he misses? Until he misses. Okay, so what does this mean? Well, this means we want the expected value, this is letter D, of a miss. And this is how these are interpreted. Because what are we doing with the geometric series? We're doing something until a success. or until what we're looking for happens. Okay, so for this first example, we were taking shots until we missed. In the next example, we took shots until we made it. Okay, so the expected value of a miss means how many misses do we need until we hit the first one. So this is the expected value here. Let me actually just kind of squeeze that in here, because that's what the geometric series finds. It finds the amount of things that happen until the first. So this would be the expected value of the first miss. Okay, well, the probability of a miss is 1, or the probability just in general is 1 over p. The probability of a miss is 1 over 0.25. And so what do we have here? What is the expected number of shots until a miss? Well, we expect 4 shots until a miss. What's the expected number of shots until the first make? So this would be 1 over p. What's the probability of a make now? So we can just kind of flop what our p's are. So this is 0.75. Do I have this on hand? No, I don't. So what's 1 divided by 0.75? This is probably some number that I'm embarrassing myself for putting in the calculator, but YOLO. So this is 1 and a third. One 1.33 shots until a make. Now, this is another point of contention. Oh crap, I'm in the way. So this is another point of contention just for these problems in general. It's okay to have decimals. These numbers are. Some may argue that you may not have a third of a miss, and that's okay. That's a valid number. I mean that's a valid critique of this. However, it's not relevant in the problem, because this expected values are models, and models are not perfect. They're just a model of the data. They are not the data themselves. And so that's what we need to be careful in distinguishing. A lot of times, especially on multiple choice questions for these, let's say, for example, if this was a multiple choice question, it would have like 1, 1.33, 1.375, or 2. And so, some students might just pick 1 because they're reasoning themselves out of picking the correct answer. Even though they have the right answer, they may say like, oh, but you can't actually have 0.33 of a make or 0.333 of a shot, actually. So yeah, so what do these expected values mean? Well, these are, for the first one, the expected value until the first miss. Well, I'm expected to take 4 shots until I miss my first one. And I think intuitively that makes sense with these problems, right? If I'm expected to make 25% of my shots, that means, until I get my first miss, I'm probably going to take 4 of them, right? The first make, a little bit less intuitive just because it's not a nice number. It's 0.75, but still the first make. So how many shots do I take until my first make? If that's what my, what I'm looking for here, I'm going to take about 3 and a third shot, or 1 1/3 shots until I get my first make. And that's the geometric series, because we're looking at how much until the thing I want to happen happens. All right, everybody. Hopefully you find this helpful, more helpful than the videos that I found. So thanks for watching.